make it because. But I'll save arc sines to the next
Hey,
round.
you want to end up like
Okay, Park was 4.
Why is pi over 6?
Oh, if you look at the unit circle, the reason for it, on my unit circle, this guy. Okay. The sine of theta equaling 1/2 happens at this point when it's 1/2. Sorry, root 3 over 2. 1/2, and that happens at pi over 6. Theta is equal to pi over 6. So to undo it, yes.
That was a 30-degree.
No, I don't put down the answer. Hey, everybody. No, I didn't put down the answer, the other side, the 5 pi over 6, because the arc sine actually only returns answers between negative pi over 2 and positive pi over 2. Okay? So if you remember unit circle, here's where pi over 2 is up here. 5 pi over 6 is over here. It's what? Beyond the unit circle, right? It's beyond pi over 2. So leave it off. Okay? So, what we're going to look at is how to do the trigonometric functions we're going to look at. Okay? We've got, there's 6 total. Okay? There's the arc sine of theta, the arc cosine of theta, the arc tangent of theta, the arc cosecant of theta, the arc Mr. Dowell. It's fine.
Mr. Dowell.
And then the arc cotangent of theta. Okay? Those are all your arc functions. Okay, basically there's one for every trig function you have.
Oh my God.
Okay? Now, there's good news.
What's that?
You don't have to memorize the derivatives of all 6 of these.
Yes.
Okay? It would be foolish to try to, I mean, you could do so, but there's far easier things, okay? There's a reason for it, okay? It's because the derivatives of arc cosine, arc cosecant, arc cotangent are just negatives of the derivative of arc sine, arc tangent, and arc secant. So that is, if I know those, all I have to do is put a minus sign out front and I get the rest, the other 3.
Yeah.
Okay? So that's why you don't have to learn it. So basically, if you were to see an arc cosine on the AP test, instead of being like, oh God, Mr. Dowell, I don't remember learning that one. If you remember what the arc sine is, you're like, oh wait, arc cosine is minus, just minus that.
Oh.
Minus sign up front.
So the derivative is negative cosine.
So basically, the derivative of the arc cosine is the derivative as negative the arc sine. The derivative of negative the arc sine. Okay? But let's go through here, okay? So the good news is these are the only 3 you need to know the derivatives of. Okay? Okay? Only 3 you need to know the derivatives of. That's just great. There's only 3 things to memorize here. Okay? The catch is these derivatives are really nasty. Okay?
Oh.
So
And I'm about to go ahead and list them.
Oh, how nasty.
No, the other 3?
Yeah.
No, they're just negatives of these 3.
Say it ain't
Okay?
so, Mr.
Yeah,
Dowell.
so it's
So
quite
what-
literally, yeah. So, alright, so going through it, okay? Here we go.
What?
Can you do the derivatives of all of those from the same?
I'm sorry?
Ricky!
Can you just do the derivatives of them all though?
They're
Yeah.
literally, you just slap a negative
You
sign.
select, so like, the derivative of the arc cosine is literally negative the derivative of the arc sine.
Can you just give us all that?
Okay? So, here we go. The derivative with respect to we're going to do it with respect to x of the arc sine of f of x is going to be f prime of x divided, let's make that look more like an f prime. Okay.
Ricky!
F prime of x over, okay, the square root of 1 minus f of x squared. Okay? The derivative with respect to x of the arc tangent of f of x is equal to f prime of f of x over 1 plus f of x squared. And finally, the derivative with respect to x of the arcsecant of f of x is equal to the derivative of f of x over the absolute value of f of x times the square root of f of x squared minus 1.
Chase Monroe saying bad words.
Okay? These are your derivatives. So, they're all kind of, nasty. Now, the benefit of it though is, as I said, you can go through. If I did the derivative with respect to x of the arc cosine of f of x, it's literally minus the derivative of the arc sine of x, of f of x, okay? So, you would just do literally this thing here and just throw a minus sign out in front, or on top. That's it. You're done. Same thing with this one right here. The derivative with respect to x of the arc cotangent of f of x is equal to negative the derivative of the arc tangent. And I'm going to give it to you, but I'm going to tell you you will never, ever, ever, encounter this one again.
Easy.
Yeah. They're not going to appear on the test. Okay. I will tell you this right now. Okay. The three I went over will be on the AP, usually in the multiple choice section. Okay. Sometimes, on very, very rare occasion, there'll be a problem involving the arc cosine on the AP. I don't think I've ever seen a problem on the AP test involving the arc cotangent or arc cosecant. Okay? And the likelihood you would see the arc cotangent long before you ever see the arc cosecant. Okay? The arc cosecant is literally worthless. Okay? Just because. It's just, cosecants themselves are kind of worthless. Okay?
Don't hurt it. I just need the stuff in the green, right? Or I need the stuff in black.
No, you need
Black.
stuff in the
Black's the only thing you need.
Black's the only thing?
Yes, because the ones in green are just
Mr. Goldstein.
negative, the ones in black.
Good
Okay.
lord.
I tell you, it's your
Okay? But these are your derivative rules. Got it?
Got it. But don't erase it.
Yeah, I won't erase.
He's pissed.
Dow Jones. I'm coming to kill you.
You guys are very chatty.
Evolution. Hi, Dean.
For the record, I personally do not like the cosecant. I just don't. It's like pointlessly difficult and it's not used for anything.
I don't like any of them.
Like literally it's not used for anything.
Oh,
Like it's an artifact.
Silly guy.
It's basically like the arc cosecant, or just the cosecant in general is an artifact of all this trigonometry. So you can describe things using the sine and cosine much better, and it's more of sort of like, oh yeah, this is from trigonometry. There's this other thing you can do to get the arc cosecant. Trust. So it's more of a there simply because. Yeah. All right. Let's look at a quick example of how something like this would be handled. Okay.
If you grab someone's thighs and tell them that they're weird, that doesn't make sense.
Okay. So, common example of this might be something like find the derivative
Hey.
of the arc sine of 3x minus 2. Okay? So, the derivative of the arc sine is the derivative of 3x minus 2 on top, so just 3, over, the square root of 1 minus 3x minus 2 squared.
Would you like expand that? Or?
Nope. Why would you expand it? No need to. The only thing you have to make sure of, obviously, is that this thing is A, bigger than 0, and B, positive. Okay? Because, well, first and foremost, the square would usually make that happen. But if I look at this thing, there's very few points this would actually work for it. Okay? And that makes sense if you know something about the arc sine. The arc sine is only defined in a very short range. Okay? It's only, in fact, the regular arc sine is only defined between -1 and 1. Okay? So doing its derivative means that you're not going to have much beyond -1 and 1. Okay? Now you could screw things around, you could make little changes to it, but really, the answer for your derivative has to be that. Okay? So x can't really be much bigger than that. Okay? In order for this thing to work. All right. So keep that in mind here. But that was an example of it. Okay? So that's what you have. Any questions there?
Nope.
All right. Another example. We did the arc tangent one. Okay. I came up here and said do the derivative with respect to x of the arc tangent.
Not a chance.
Shame
I'm
on
gonna
you.
string you guys up by your toes.
Stealing
Okay.
my pizza. Start over.
So I do this one right here. Arc tangent's a little bit friendlier. Okay, you don't have the square root on the bottom of it, but otherwise it's exactly like the arc sine. So it's going to be the derivative of this, which is going to be 8x minus 5 over 1 minus all this thing squared. Okay, just like so. Okay, so big nasty function. Okay, but doable, right? And with this one, the only requirement is that the bottom has to be bigger than 0. Can't be 0. Okay, it can be negative, it can be positive, it just can't be 0. Okay, arc tangent, in fact, is defined everywhere. So its domain is from infinity to negative infinity.
Didn't it say 1 plus?
Is it 1 plus?
Yeah, it's 1 plus.
Oh, did I make? I always mess up the signs. You're absolutely right. 1 plus. Again, this. In fact, it's squared, so it's always positive. There you go. It always exists. Okay. All right, but you get the idea here, right?
Got it.
Okay. The only last thing you would see here, okay, would be integrals involving these, okay? And the integrals are quite literally, they hardly ever come up, but they're just u substitutions turning things around, okay? So if you saw the integral, for example, of dx over the square root of 1 minus x squared, that's my arc sine. Okay? The integral of dx over 1 plus x squared is my arc tangent. Okay? And lastly, the integral of dx over absolute value of x comes to the square root of, what is it, x squared minus 1. That's my arc secant of x. I would say this, anytime you see any one of these three come up, they are going to be u substitutions, okay? And so the dx here is the derivative of whatever x function is down there. But what becomes nasty here is notice the x's are all squared, okay? And derivative is strictly the derivative of x, not x squared. So you would have to figure out if that thing is a squared x, write it as such, and then be able to do a u
Under a
substitution.
root, wouldn't that be like a chain rule? You have to like deconstruct a chain rule?
If this was, yes, but in this case here, these are all special, okay? These do not behave normally, okay? These are not going to be easy, okay? You're not going to see these very often, okay? So really, if you can get this down, these integrals down here, you should be fine, okay? Because this is probably about as much as you're ever going to see, okay? You might see something, let me give you an example though. You might see something like, if I give you like the integral of the square root of 1 minus well, I'll have to give you an example tomorrow. Okay.
Howard, you're an idiot.
Okay. All right.
Oh, Sam, I gotta ask the team if we can play tonight.